Hi and welcome to the webinar, Making the Logical Data Warehouse Our Reality. Glad you can join us. Today your presenters are Jonathan Wisgerhoff, I'm a Senior Architect at Kadenza, and Mark Pritchett, Technical Director from Northern Europe for Denodo, is also joining the webinar. What's on for today? First have a look why to choose for data virtualization and where does it stand today. Then we go in depth on how data virtualization really works, and Mark will explain that, and we will do a demo with Denodo and see how a data virtualization architecture can be realized. What can you expect? We aim for 3 quarters of webinar time, so we want to give you a really good look on data virtualization and how it works. Well, where do we stand today? Or what did Gartner predicted back in 2012? In that time, they say the logical data warehouse will form a new best practice by the end of 2015. Well, we are at the start of 2016, so it's good to see what was the prediction and what has been realized of that promise. Back in those days, in 2012, the logical data warehouse was at the peak of the hype cycle with overinflated expectations. And really the enterprises were ahead of the game, were serious looking into the logical data warehouse. But still, it was a bit like chasing the pot of gold at the end of the rainbow. So the logical data warehouse was more of a theoretically promise, and it still needed to be realized in practice. So now in 2016, we go to have a look, was Gartner's prediction correct in that time? Well, when we look today on where do we see data virtualization being used, we see it's a maturity and it's adopted by more and more enterprises globally. The data virtualization layer has taken important parts in current architectures at enterprises, and we see data virtualization is used across a lot of different industries, and data virtualization enables really in projects to be truly disruptive. New markets and new opportunities can be explored, and you can be more competitive because data can be a leading asset in your company, and you cannot wait for the huge slow project and wait before it is delivered. You can just in parts of your architecture really have the benefits of data virtualization. And data virtualization is now more mainstream, and the logical data warehouse is not longer just a theory. But data virtualization really has become a reality, and that's what we like to show you today. When we look at the real world of data, we see a lot of data sources, and all those data sources are trying to connect and consolidate it from core systems all together to satisfy reporting needs. And over time, architectures get extended a lot, and not all the data is still available in the warehouse, because more and more data is created inside the company, but also in the outside world. And for example, external data sources needs to be more included in architectures than before. For instance, marketing databases with marketing efforts in their promotions, marketing, advertising. It's going really fast, and data is created all over the place, and it's a real challenge to incorporate those all in an enterprise architecture. And also we see markets are expanded with lots of different systems over different places, and also data is more and more offloaded or archived on Hadoop clusters, and combining and consolidating this all in the current architectures is a real challenge, because in the end business users want one holistic view of the data across all these systems, and what can really help them is a logical data warehouse where they don't need to think where is the data stored and how and how can you combine it. One solution without data virtualization is putting everything in the enterprise data warehouse, but the data warehouse is stretching it seems. It takes too long to get all the data into the data warehouse, and more data needs to be replicated. And the impact, for instance, on storage, but also on security and governance, is really huge. And for instance, operational BI, where you have where you want to deliver more and more real-time data, can be a real challenge. And these are just some examples of all the challenges there are with incorporating more and spread data into your architecture. So let's have a look. What does the business really need? They want to have a canonical view, and they want to see it in the as a business user, and they want to have a business view on their data, on the parts they really see in the business. So for instance, here we have a typical retailing company, and these are the information topics they want to see, and they want to see data across all the multiple channels and navigate between those entities over business relationships, and not which system is the data coming from. It's just a business view on the data. And business users really don't want to be spending their time at integrating multiple physical sources or data needs to be replicated or copied to systems. So they need a pre-integrated information layer that on ad hoc basis can deliver the right data, is trustworthy and accurate. And this canonical view made for the business need is really something that can be done with data virtualization. And how data virtualization can bridge that gap, that's one I want to give it over to Mark and explain on that. Go ahead, Mark.
Thanks, Jonathan. So what I'll do is I'll spend a few minutes discussing the capabilities of data virtualization and the capabilities it provides to really bridge this information gap between the logical world required by the business and the physical world of the data sources. And then I'll try to illustrate that with a short and simple demonstration of Denodo, really in the context of a logical data warehouse. So data virtualization, it really bridges, it's designed really to bridge this information gap that Jonathan described between the physical world of the data sources and the business-centric view that's required by the consumers. And as shown in this slide, data virtualization is really providing a model-oriented view of the data that's more easily and better understood by business users and consumers, and it maps this model virtually to the heterogeneous data sources and data infrastructure underneath. So this model, logical model, is published as a virtual database that in Denodo that allows users to query the data model and retrieve the data as if it was all located in the same source. So this provides a lighter method of integration that involves less physical staging, less replication of the data, helping to reduce the costs associated with replication, and it published these models in reusable ways that the models are then easy to combine and easy to change. So data virtualization really, it's aimed to ensure high performance by allowing processing to be taken to the data rather than bringing all the data to the processing. It supports in these types of scenarios self-service access by publishing data in multiple access patterns, not just publishing this model as a SQL queryable set of objects, excuse me, but also allowing users to search and browse for data, and also provides the ability to provision data in real and right time, so through on-demand data access, through caching and scheduled batch extracts. So how does data virtualization work? So this slide really describes how firstly we need to construct a logical data model, and at design time Denodo enables the users to connect to the heterogeneous data sources and import the metadata from those data sources. Then modeling tools are provided that use this metadata and allow the user to build up logical views that represent the required business-centric entities and relationships on top of the data sources. So these views really define how the sources need to be accessed, how the data is to be combined at runtime, and then also the publishing methods, or in other words, how the data is to be accessed. Once the model is published, users are able to discover data that's available in the virtual database or through the virtual model through global search facilities, so Google-like searches on the published data. They're also able to provision data as linked data services, allowing users to navigate the published views more intuitively through a web browser. Also allows users to discover the data that's available or the views that are available in the virtual database through metadata search, so allowing users and developers and consumers to locate easily relevant parts of the data model that's published in the virtual layer. So that's design time. But then at execution time, when we want to access the virtual model, data virtualization ensures performance and scalability of the queries that are executed against the virtual database, and really provides enterprise-grade management of the virtual layer. So I guess if we consider firstly performance, obviously that's really key in data virtualization, and Denodo provides a sophisticated optimizer that ensures queries are executed in the most performant manner. So this allows queries to be rewritten on the fly to be more efficient or most efficient, allows delegation of processing as appropriate to data sources, for example. Also, Denodo's virtualization servers scale both vertically and horizontally to handle any type of workload that might be applied to the logical warehouse. And the caching capability is also provided to ensure that the performance of particularly complex queries is good, and also to protect potentially non-performant or sensitive operational systems from increased sort of query load. As well as performance, enterprise-grade management capability is also provided by Denodo, and governance of the virtual model is obviously really important. So the virtualization layer provides metadata management and data lineage capabilities that assist with audit and impact analysis. Monitoring and audit is obviously key, not just for monitoring resource usage for performance reasons, but also understanding in the logical warehouse who has accessed the data, which data has been accessed, and when. And a comprehensive security model is also provided that really enables the virtual layer to define very granular role-based access privileges across the virtual database, so that you can be sure that users accessing the logical warehouse only see the data that they're entitled to across the heterogeneous data sources. So, how, given those capabilities, how does data virtualization really enable logical data warehouse? So using those capabilities, it's really able to make the logical data warehouse a reality now. So data virtualization really supports agile delivery of information in this context. So it allows data, not all the data, have to be replicated into the centralized data warehouse. Data that doesn't need to be in the data warehouse or is better left in a more appropriate processing platform can stay where it is. But data can still be made available to consumer in a consistent manner through a single point of access through the virtual layer. So for example, data virtualization allows the data warehouse to be extended with data from external systems. It enables companies to bring in NoSQL databases to allow them to do to offload data from the warehouse for cold storage, for example, offloading from the warehouse, but still enabling them to get a complete view of current and historical data across the archive and the warehouse. Supports operational reporting as well, so enables much more data to be accessed directly from the source systems to provide right-time processing and more operational reports. And data virtualization also enables flexibility. So for example, virtual marts can be built on top of these data sources very quickly without having to physically move and transform all the data to help meet the changing needs of the business. So in the demonstration that we'll walk through shortly, basically I have a logical data warehouse environment that's set up on my laptop, which is based on this scenario, for which data is distributed across several data stores comprising this logical data warehouse. And in this scenario, the logical data warehouse is to support a fictitious global sporting goods distributor. And for this distributor, for example, we have sales information that's held on a warehouse in SQL Server, and also we have historical sales data that's stored in Hadoop, and online sales transactions for a separate channel to market that are held in a separate database. And in this scenario, the company's customers are really large global retailers that actually sell the sporting goods that they distribute. So the retailer or customer data is also held in the warehouse, but it's also distributed in the CRM system. It also needs to be extended with sales lead information that's held in the cloud in Salesforce, and also the company needs to get an understanding of the credit worthiness and their credit exposure to their customers or retailers by getting their credit rating information from an external credit rating web service. There's also additional entity information held in other systems like products, orders, promotions, employees, etc. What we'll see in the demo is that we'll see a dashboard, a global sales dashboard that's shown here, that we've created in a BI tool, in this case Tableau, and that's able, and this dashboard, is able to show sales information by product and retailer across all these distributed data sources using a single connection to the logical data warehouse. So this data warehouse is built on top of a virtual sales mart, which includes a virtual sales fact table shown in the center here in this schema, and that's related to a number of dimensions holding retailer information and product dimension information. And the BI tool will see this schema like any other relational database, but actually underneath this schema, the virtualization layer defines sales fact view as a combination or a union of current data held in the warehouse and historical data in Hadoop. And also the retailer dimension, virtual retailer dimension, that's defined in the virtual layer combines information from the core enterprise data warehouse, but that's augmented with information from Salesforce, providing the lead source, and also the credit rating information from a third-party web service. So what we'll see is that in execution time, the BI tool can run a SQL query against this virtual schema, and the data virtualization engine will break that into subqueries, execute it in parallel against the data sources, and convert those queries as necessary to appropriate API calls, for example, to the web services. And the data that's pulled back is returned and combined and then presented to the BI tool and user as if it all comes from a single database. Okay, so let's have a look at the tools in action. So firstly, what I'll do is let's look at our dashboard that we just looked at. So this global sales dashboard, which, as I said, has been built in Tableau, and this shows product data from the ERP system, shows lead information shown here from Salesforce.com, and it shows sales data that's held here both in the warehouse for recent sales and in Hadoop for historical sales. And all the data that's reported on in this dashboard is accessed, as we said, through the logical data warehouse, implemented in Denodo as a single virtual database. And the virtual database can be consumed by many different clients using standard connections. So whatever BI tool you have in the enterprise, all those tools get to reuse the same data through the logical warehouse. It doesn't matter whether it's Tableau, whether it's ClickView, whether it's Excel, Cognos, Business Objects, for example. So for the BI developer connects to the virtual database using a single standard database connection. In this case, in the case of Tableau, we're using ODBC. So we select our virtual database connection and connect to it. And the BI developer sees all the views that are available and published within the logical data warehouse, and they can use those to query and combine them using standard SQL. So for example, here we can pull in our virtual sales fact table, which we looked at, which we mentioned earlier, and this is a view that provides sales information, recent sales information from the warehouse combined with historical sales from Hadoop all in one place. We can also pull in retailer information. So if I look at my retailer extended dimension here, we can see the data behind this view. It provides data, core data that's shown here from the warehouse, but it's also augmented with credit rating information coming from a web service, third-party web service, and lead source information, if I can find it here. Lead source information that's coming from Salesforce. So I can drag that table into the reporting tool and simply do a basic join, for example, to join that data together within the BI tool. So here, this view is pulling together. This query is pulling together data from the warehouse, augmented with lead information from Salesforce and credit rating system with third-party web service, plus information from Hadoop, and all this is joined together seamlessly by the virtual layer, and that means that the BI developer doesn't have to worry about integrating all those data sources together across all those heterogeneous data sources. Well, that's done in the logical data warehouse for them. So let's switch hats for a moment and consider perhaps a more application developer or a data scientist role, and how they might access and use the logical data warehouse. So these type of perhaps more technical users are able to connect to the logical data warehouse and query the data using more development-based or statistical analysis tools in the same way as the BI user. Here you can see I have a standard SQL client tool here, third-party SQL client tool, that I've connected to the same logical data warehouse that we were just using previously with our BI tool. But in this case, I've connected to the virtual database for the logical warehouse using a JDBC connection. So the virtual database defined in Denodo exposes all of its metadata to the client tools. So you can see here that all the views that are available to be queried or published in the virtual layer are visible to the user. And you can see here that we have a retailer virtual sales fact. If I open that, we can see that we can also get the relationships from the virtual database or the logical warehouse. And we can see that we've published this sales fact actually as in the star schema with related dimensions, virtual dimensions associated with it, which are then available to be queried and understood by the developer. So again, the data scientist is able to query these views using SQL, and here I have an example of a query that's running a reasonably complex aggregation of the sales across multiple dimensions, across the time dimension, the retailer dimension, and product dimensions. They're all published in the logical warehouse. And when I run this query, Denodo, Denodo is receiving the query via the JDBC connection, it's optimizing it, it's generating subqueries that are used to access the various data sources, and then it's presenting the data back to the client as if it all comes from a single database. But for the data scientist or the developer, again, this means that they're able to spend more time analyzing the data and less time having to integrate and prepare it across many data sources that comprise the logical data warehouse. Okay, so let's look now at the lowest level and see how Denodo has actually created this virtual database that forms the logical data warehouse that we've been able to query through these various tools. So this is the Denodo Virtual Database Administrator tool, and this is very similar to an enterprise relational database management console. So it allows users to administer security with role-based access, access control, user management. Allows you to configure and optimize the server configuration, for example. We can also monitor queries that are running against the virtual database, set up and invalidate the cached views, for example, also publish web services. And in this case, we can see on the left-hand side here, we have our global sales virtual database that I've connected to. And this is the virtual database that comprises the logical warehouse. And folders on the left here help us organize the views and artifacts defined in the virtual database. So firstly, let's just open one of these folders, look at the sources folder. So this holds all our data source connections that we want to connect to all the various heterogeneous data sources in the logical that we want to connect to in the logical data warehouse. And Denodo can connect a whole broad spectrum of data sources, be it standard databases, warehouse appliances, through enterprise applications, web services, Hadoop-based systems, etc. So if I open one of these, let's look at our connection, for example, to our SQL Server database. So first, when we build up a logical model, we have to connect to the data sources and we have to import the metadata from them. So in this case, we can see the schemas that are available in our enterprise data warehouse. I can select the various tables that I want to pull in the metadata for into their warehouse. I can click on the button, and what's created are these grey boxes which are shown here, which are what we call in Denodo base views. So a base view is really a one-to-one representation of the underlying data source. But what that allows us to do is to execute SQL statements and queries against those data sources through Denodo. So what happens here is that Denodo runs the query, it translates that into an appropriate flavor of SQL in this case, which is then delegated to the underlying data source to get the data. And that same process is used no matter what the type of data source. So whether we want to connect to a database or to a web service or to Salesforce, for example, the base views that we created allow us to apply relational algebra or SQL-based constructs to them and allow us to join and combine those objects using a common language. Okay. So if I open the folder that contains our star schema, which we've talked about. Sorry, let's get the right folder. Then we can look at some examples of the views that we've been querying previously. We can see here the list of the dimensions that are available that we saw in our third-party tools, and also a list of the fact tables that are available to be queried by third-party tools. And what I'll do is I'll look at a couple of these to illustrate how they work. So first of all, let's look at our retailer extended dimension. And if I open it and then look at what we call the tree view, you can see the logic that's actually comprises this view that's published at the top here. So we can see that it comprises of connections to a number of data sources. Here we have SQL Server, Salesforce, and credit rating web service. And these first boxes that are shown here, second nodes up, these are the base views that we described earlier, and these allow us to combine data across Salesforce and the credit rating web service using standard constructs such as relational algebraic constructs such as inner joins, etc. Here we've got simple joins which join our retailer dimension in our warehouse to our Salesforce lead information in Salesforce to our credit rating website to get the credit rating for each retailer from an external web service, I should say. And then we've defined which fields from those data sources are projected to comprise the view that we want to publish or query. So we can see that it joins these multiple sources together, and if I run a query to select data from this view, Denodo is basically, as we talked about, decomposing the query into appropriate subqueries which are executed in parallel to those underlying data sources. The data is combined in Denodo and presented back as if it all came from a single place. And we can see that if we look at the execution trace, which shows the actual process of doing that combination. So here, if I click on the bottom node, we can see the actual query that's actually been delegated, in this case, to the SQL Server database, and we can see another query here that's been delegated, in this case, to our Salesforce data, which is actually held in a cached database. Okay, so if we look now at another good example, we can see the retailer sales virtual fact. So this is a fact table that we've been querying in our BI tool. And again, if I open this tree view, we can see that this is, in fact, is a union between two data sources shown at the bottom here. So the first is our enterprise data warehouse, in this case on SQL Server, and on the right hand side here we have our historical sales, which is held in a Hadoop database using Hive. So this is a union across those data sources to combine them to give a consolidated view of sales across the recent sales in the warehouse and the historical sales in Hadoop. And again, if we execute a query on this view just to select everything, we can see that it should return over 500,000 sales facts from the two data sources. So you can see it's 565,000 records. And if I look at the execution trace, again, we can see that this is comprised of two queries, one that's been delegated to the enterprise data warehouse, and another that's delegated to our Hadoop Hive database to bring back the data. And then the resulting data is unioned in Denodo and presented back to the consumer through the query as a result of the query. So we can see here that in Hive there's 120,000 records, but in our warehouse there's 450,000 odd records. So if we look back at the tree view, I just wanted to take the opportunity to show you an example of one of the many sophisticated optimizations that Denodo provides to ensure performance in this type of logical data warehousing scenario. So here in the tree now we can actually see that on each of these branches of the union, if I click on this, we have a select condition or a partition key that's implemented. This is telling the optimizer that in the SQL Server database or in the warehouse, that sales newer than 2011 reside, whereas in Hadoop we're telling the optimizer that sales that are older than 2011 reside in Hadoop. And these partition keys allow the optimizer to prune branches that are unnecessary when a query is run that includes a reference to these partition keys. So let's have a look at an example of that. So if I rerun an example query, but this time I add in our order day key, and perhaps we want to look at historic data only. So I can select data where the order day key is less than basically 2011. If I execute that query again, what we should see obviously is that data is filtered and less rows are returned. So in this case, rather than the 500,000 rows, now we only see the 120,000 rows from our Hadoop historical data sales. But if I look at the execution trace, what we can see is actually that rather than before we had multiple branches of the tree, the Denodo optimizer has optimized and simplified the tree, simplified the execution tree. So now it knows that because we're only interested in historical sales, it's only executing a query, for example, here against our Hive data source. Okay, so that's a good example of how Denodo ensures that queries are in a logical warehouse executed as efficiently as possible, and only the data that's absolutely necessary to answer a query is actually pulled out from the data sources to ensure that the data is returned efficiently and quickly to the consumer. Okay, so what I'll finish off is just to show a couple of examples of the governance capabilities provided by Denodo. So one of the important things in the logical warehouse scenario is to enable is to ensure that consumers understand where the data's come from in all these distributed data sources. So Denodo provides a data lineage functionality. So if I open my retailer extended dimension again and I click on my data lineage view, we can see here all the columns of the retailer view that are shown here. If I click on one of these, we can see on the right hand side that the tree is animated to show where each of these columns come from. So in this case, we can see here that a credit rating comes from our credit rating field from our web service branch. Our lead source, if I click on the lead source, we can see the lead source here comes from our Salesforce data source, for example. And similarly, if I click on something more meaningful, perhaps our contact phone number, we can see that that information is coming from the warehouse. So all this type of lineage information is exposed also via a metadata API. So it can be exposed as a SQL queryable view, for example, to external applications as well. So this metadata lineage information can be published to Excel or via a reporting tool, or even be published as a web service for consumption by external users as well. The last thing I'd just like to show you is also we have for impact analysis. It's important as well to understand, because of the reusability of all of the views that were defined in the logical warehouse, and we can build on top of those. It's important to understand how those views are used and how they're dependent on other views. So we have a used by analysis that again is useful for impact analysis. So if we want to change the retailer extended dimension, we can see all the other views which use or built on top of this view. So here I can see there are 3 views. So I have a consolidated aggregated view of retailer sales by lead source, which is built on top of my retailer extended dimension. I also have another aggregated or a couple of other aggregated views that also use this retailer extended dimension. And using this capability, we're able then to assess the impact of change to any of the views in the tree and take development decisions about how we want to deploy or change or propagate changes to all the dependent views. It's very important in the development environment. Okay, so hopefully that's given you a flavour of how the virtualization tool, data virtualization, works, how we can build this logical model to build up a logical data warehouse, and how that can be easily consumed and help simplify consumption of data by consumers, various consumers, whether it be BI tools or whether it be from a more development-oriented approach using by a developer or a data scientist, for example. With that, I'll hand back to Jonathan.
Mark, many thanks for the great demo. Yeah, for me, I think the key points are you can get from this demo that data virtualization is really mature, and it can be a strategic component of an enterprise architecture. And second, data virtualization really enables the logical data warehouse as we have seen. It's no longer a theory or theoretically architecture pattern. Companies can really getting value from it. So thanks a lot for showing that. So what I want to encourage to the webinar attendees is see what data virtualization can mean for your organization and how you can find your pot of gold. You see him here in the left. What we like to give you is see and explore how data virtualization can empower your business, and lower your time to market and lower your total cost of ownership. And you can explore that by getting in touch with us, with Kadenza or Denodo, and see how we can help you on more knowledge of data virtualization. Or consider conducting a proof of concept in your own environment with your own data to have a really good proof what data virtualization can mean for your business. And when you want to start right ahead today after this webinar, or maybe tomorrow, try and download Denodo Express. It's just a complete version of Denodo, and you can really explore what the Denodo platform, how it works and what it can do on your data. So on that, I want to end this webinar. Mark, thanks a lot again. And after this webinar, I will send an evaluation email so we can get in touch with you all. All right, thank you.
Thanks very much.